Let me get my Twitter going here. Where is my link to my stream? How do I share this link with someone? There we go. I'm gonna say on Twitter, come join me and learn about Redis cache. Where's Redis? Hello, Paul. How are you? Just giving a few more minutes here. Going to be learning about Redis today. Taking this from a pretty fresh perspective. Don't really know much, just know it's a caching solution. So let's see what we can learn about it today. And so I found this pretty cool article. I just kind of stumbled on it. I was interested in whether or not Redis can be used as a primary database. Because as far as I recall, at least at the time when I looked into this initially, there was no persistent storage. Hey, Painflow, how you doing? And it seems like this is no longer the case. It seems like there's some kind of persistent storage layer, which is making it so that folks are getting really excited about Redis. And also that they support a whole bunch of different things like streaming and all that. And I think grouping as well. But again, don't know too much. So we're just going to go through this article and then I may watch a YouTube video just from that I came across. And then I'm going to do the tutorial, which is let's just kind of play with Redis using the syntax that's familiar on that tutorial. So anyways, let's get started with this article. Hopefully this is big enough where everyone could see. If it's not big enough, let me know. Okay. So for many applications, there exists a database and a cache. Each time data is needed from the database, the application has to do a short choreographed dance. Ask the cache for the data. If the cache doesn't have the data, ask for the data from the database. Take that data from the database and populate it into the cache, and then get a reply from the cache. So this is a pretty standard pattern. This is how you keep the cache primed with data, so that once you go and retrieve it from the source, you do the work to put it in the cache so that the next person that comes along is also going to have access to that item. Actually, let me move my webcam because I think, at least on my screen, this is blocking. Hopefully this works. I should have moved to the bottom left now. Anyways, let's keep on going. So again, pretty standard pattern. You ask for an item from the cache. If it's not there, you go and get it. Then you put the item for the cache into the cache, and then the next person that asked for it already has it. And the argument here is that this is a complicated thing to do, which, I mean, if you abstract it behind some kind of interface, it's not complicated, but it does add overhead, right? Because you need to do all those extra steps. And it does add some unpredictability to your application, because if you have something where you're looking at more than one item, for instance, you may need to do multiple trips to get all the items if they're not in the cache, and then put them into the database. And depending if the if the cache protocol supports batch reads, batch writes, then you may have a hard time here. Anyways, let's keep on looking at this. So slow databases, so complexity. This dance has significant complications in terms of application logic, connections between multiple services, and multiple potential points of failure. So browser, application, okay. Why is this dance necessary? Simply put, to make up for the database being slow. Okay, kind of. I mean, I don't really buy this argument, because certain databases are meant to do different things. And to make a statement like this is kind of ignorant in my mind. I'm sure you're not going to be able to get all the benefits out of an Elasticsearch cluster, for instance, inside a Redis cache. I'm sorry, but that's not going to happen. You can do some great groupings there and all sorts of crazy text-based searches, and that's not going to happen in a cache. So I don't like this argument. Do you always need to have a slow database, a fast cache, and an application that is coordinated between the two? Sure, sometimes you do need a big, complicated, slow database to undergird a big, complicated data model. But very often, this kind of database architecture is simply superfluous. And if you can manage to avoid using a separate, slow database, you can have a single data layer connected to your application, which presents many fewer opportunities for slowdowns and failures. See how it works? Let's take a look at building an application. Use a single data layer with Redis. So if you recall what they're showing up here, they're showing this cache scenario where you have to, from the application side, read from the cache, go get the data, and then write it back into the cache for later. And their argument is saying that the application doesn't have to read the database. All it has to do is look at Redis, and somehow that's going to always solve all of your problems. I'd be careful with this, because when they sell something as with all these promises, usually they tend to do none of them very well. So be careful about that. Okay, so the primary reason to build an application without multiple data layers is to reduce complexity. Operationally, anytime you can remove an entire layer from your stack, things are vastly simplified. True. You no longer have to worry about the database and cache both staying up, and you also don't need to worry about two sets of upgrades: security protocols, resources, or underlying infrastructures. All right. I mean, this doesn't apply if you're using a local cache, not a distributed cache, but that's a different thing. Scaling both cache and a database is often complicated. Each data layer scales differently, reaching an infrastructure and optimization opportunities at different times. Additionally, reducing the number of moving parts reduces latency, even though any given piece of the architecture may be fast. Okay, this is kind of boring. I'm just kind of skimming this through. Okay, so the argument here is that reduce complexity by only having one layer. Okay, fine, I buy that. That makes sense. Okay, so choosing the right database. If software is an exercise in engineering, part of building great software is choosing the right database. Good engineering is not only about selecting things capable of supporting the design that are not overkill. This is very true. There's a famous acronym. It's called YAGINI, I think. You ain't gonna need it. What we tend to do as developers, engineers, architects, whatever you want to call it, is we like to build complicated things that can handle very generic use cases, because generic software is good software, right? But often we do so at the cost of significant overhead and complexity and time that it takes to actually deliver the feature. So I agree with this. Don't over-engineer something if you don't have to. I feel that it's better to iterate, try something, see if it works, iterate, make it better. Just don't make one-way door decisions where if you go down a certain path, you can't get out of it. Always be sure that if you're making a decision, it's something that you can back out of later. Excuse me. And correct if you need to correct it. Anyways, borrowing from civil engineering, why build a bridge using 9,000 tons of concrete? 100 tons will get the job done. Fair. Many applications have relatively simple data needs, which can easily be supported via Redis built-in data structures. So do they, I'll probably find this out in this article, but do they support anything more than just a key or a list of keys? I wonder if they support any other types of queries. They're kind of selling this as something that's very generic and very useful. I wonder if it could support something as basic as that. Other applications may need a bit more from the Redis. For them, Redis provides an extensible engine that allows modules, oh, here we go, to add just the capabilities needed and no more. This approach extends to durability. Redis gives you the option of being entirely ephemeral, achieving durability through periodic... Bad. That's bad. On-write durability with an append-only file. Okay. Redis can make the optimal trade-off between performance and durability depending on your use case. So the way it maintains state, or like if it fails needs to come back up. So let me explain this, like how this works with traditional caches. Traditionally caching, it doesn't have state, right? If your machine goes down and that thing's down, then you lose all the data that's on that cache. And when the cache comes, when the host that is fronting that cache comes back up, then you start from scratch, right? That's just the standard pattern of how caches work. And this has been a problem with caches because you nuke your cache, right? When you bring the service down for anything like a deployment, like a security vulnerability upgrade, anything that you need to do to bring your service down, your application process down, is going to result in having to wipe your cache. So what they're saying here is they don't achieve like the traditional sense of the term durability, in the sense that you're persisting this data either on disk or something like that in real time. But they're saying here that they do it through periodic snapshotting or append-only files. So it's just a log file that they're continuously writing to, and that's supposedly the ledger for state. And I wonder how this works in a distributed environment. Is this coordinated from the distributed perspective? So if you have multiple nodes, do they all kind of make a decision that is consistent across all of them in terms of what the order of things being inserted into the cache are? So I'm curious about how that works. So let's keep going. Redis and the power of a strong community. Okay, it's got a good community. I'll give it that. Redis and the power of simplicity. One reason Redis is so widely used is simple to understand deeply. Redis gives developers building applications the tools, information they need in an efficient manner. It's got good documentation, computational complexity. Okay, so they push for performance. I'll buy that. I like that. Other databases often act as black boxes, either because they're closed source or because the open source is too massive. Okay, so it's BSD license. That's good. Scaling. Okay, so this is interesting. How does it scale? So when building an application, it's important to think about a particularly good problem. What happens when your application is successful? It's a good problem to have. A successful application has to scale in a couple of ways. You have to scale up the throughput and scale out the data size. Scale up the throughput. Right. So if this doesn't make sense, you need to increase the amount of throughput that you can handle, but you don't want your objects that you're storing to get bigger. You just want more objects, right? That's how you scale horizontally. If you just scale to the point where your objects are getting bigger, then you're scaling vertically, and this is a design flaw. Redis is synonymous with in-memory data storage. Using DRAM is the fastest practical method of storing data in computing, so this doesn't require further optimization. Redis Enterprise is designed to scale in non-linear fashion. It's demonstrated, okay, it can handle a lot of ops. In short, adding more hardware to your cluster gives you additional throughput without hitting plateaus or walls. So it seems like you just add additional machines to be part of your node, or your nodes, cluster rather. Scaling out can also be achieved by adding more hardware, but to be more efficient with your infrastructure budget, you can use Redis on Flash, which lets you address dramatically larger data sets at lower cost with minimal impact on throughput. Redis on Flash automatically extends DRAM storage into SSDs, keeping the hot values in memory, and moving the cooler values onto flash memory. Okay. Also enables scaling across the globe with active deployments. This means a single dataset can be replicated to many clusters spread across wide geographic areas, with each cluster remaining fully able to accept reads and writes. Redis Enterprise uses conflict-free replicated data types to resolve any conflicts automatically at the database level without loss. So this is interesting. So they talk about Redis Enterprise here. So what's the hosting provider for Redis? Let's do quick old Google lookup. So Scale Grid, Redis Labs. Okay, so I think they have their own, right? That's what this is? Yeah, so of course they have their own. I'm sure AWS has something too. What's the cost look like here? For development environments and low throughput, hosted on demand, 99% uptime. Just to try it, you have to pay. I mean, something like MongoDB Atlas is great, where you don't have to pay for anything. It's like a sandbox environment, but no bueno. Don't like that. Okay. So they have their own hosted thing. I'm pretty sure AWS does too. So Redis, AWS, yeah, offers Amazon Elasticache, fully managed in-memory data store compatible with Redis. There you go, or Memcached. Powerful real-time applications with sub-millisecond latency. So the thing that you got to watch out for is version mismatch. So typically when Amazon kind of absorbs a product or offers one product, they're usually a couple versions behind where the head of the product is. For instance, their document DB, which is a hosted solution for Mongo, is a little bit behind. And I would assume that the case is similar here, but that's just something to be aware of if you're making any decisions. Let's keep going. The future is byte addressable. Having a future-proof database helps ensure that it won't rapidly become a legacy hindrance. Okay. So byte addressable storage, spinning disk hard drives. Okay. They are addressed through hardware, software, spinning disks. Okay. This is not interesting. Data for performance is forever. Expectations for performance are not going away. You'll never hear a business leader say, I wish the database was slower, obviously. Thinking about building a modern application involves making them real-time, easy to develop, operating elegant, scalable, and future-proof. Sure, Redis makes a great database cache, but expanding Redis's role, caching to a primary database gives developers a head start on building the applications of tomorrow. I'm a little bit nervous about this. Oh, sorry, there's a ambulance there. Where was the part about storage where they were talking about that they had no redundancy or no durability? Maybe if I just control F for durability, you'll probably find it. There we go. So this makes me nervous, this whole section right here. Because you can't really have something as a database if it's not like able to recover in the case that it goes down. So this is scary. Big red flag. So I wonder how that's solved. If it's solved. Anyways, let's, so I have a video I want to watch and I hope it works. So I found this earlier and it's kind of the same topic. Redis as a primary database.
Presentation. Please.
Let me know if you guys can't hear the audio for this. I believe you should be able to. I'll put closed captions on just in case.
Oh, okay. That's me.
Let's see.
All right. Redis as a primary database. Well, as you all know, Redis started as some sort of caching system and gradually evolved to become a database. We at Redis Labs make a lot of effort to make Redis a primary database for as many use cases as we can.
I mean, this is tough for him, right? Because he's trying to sell his product to people that want durability. And Redis just doesn't offer that. Because typically it's a balance between performance and other things that you need to sacrifice. Durability being one of them. So I'm interested in seeing how he tries to sell this. Let me know if you can hear, by the way. Or someone please tell me if you can hear. That's also helpful.
And today, we would like to share with you some of the innovations and demonstrations associated with Redis as a primary database. And I'll start with the functionality of Redis as a multimodal database. Well, modern applications use what we call Polygon persistent architecture, by which multiple microservices communicate with one or more data services, databases, and then those databases communicate among themselves and send data to one another.
That's not always true.
The limitation of this approach are, first of all, there are too many network hops which may make the application slower.
Partially true. The problem with this is that with this infrastructure, with more network hops, like the counter argument of his statement here is that with more data stores, you get redundancy and you get different solutions that are good at different jobs. So a common phrase is pick the right tool for the job. Redis is trying to be everything, seems like.
Secondly, you have too many data services, too many connectors, too many glue components, and it tends to get complex, this setup. It tends to get complex and also expensive because on the cloud, you pay separately for each of those microservices and for each of those data services.
That's true. I mean, if you're just hosting some EC2 machines, then fine. But if you're paying for all these different fancy products, then it's fair. Hey, Farzad, how's it going, man? Thanks for joining. Painflow. With microservices, you generally keep the services as atomic as possible. That's true.
Another modern approach is to use what we call a multimodal database architecture, by which the microservices communicate with a single database, which has all those separate functionalities of multiple type of databases.
You know why this is a bad idea? Single point of failure. This thing goes down, literally every part of your application is done, right? So this is a hard sell, right? Because they're saying that there's a problem with the current way to do things, which is pick the right tool for the job, have these multiple different databases that are good for certain things, and kind of coordinate the orchestration between them, right? If you want to do a fuzzy text-based search, you go to Elasticsearch. If you want to do a quick lookup, you go to Mongo or Dynamo. But they're saying, no, don't do any of that. Just use this one thing and add these modules as you need them to get the functionality that you have. And oh, by the way, you don't get durability. And you get single point of failures here. So this is not a good idea.
And this makes things much simpler, of course.
Much simpler, of course. Yeah, Painflow exception, you hit the nail on the head here. It definitely better be multi-AZ, but I'm sure you're going to have to pay a premium for that.
In the case of Redis, we implemented the multi-model functionality with a novel concept, which is called Redis modules, which was mentioned here before. Basically, we have a core part of the database and then an API, which enables anyone to add any C, C++, Python, Go library to the database and make it an integral part of the database.
That's kind of cool. So you can add your own kind of hooks to do whatever you want. And I suppose that as long as you build on their interface and build on their, like whatever's offered as part of this SDK, then you can kind of build a very custom tailored solution, which is pretty cool.
Now, the nice thing about this approach is, first of all, it's modular. So those different type of database functionalities are not tightly integrated as you find with some of the other multimodal data.
Okay, I call BS on that one. So not tightly integrated, okay? Isn't there only one data store, right? Are they copying data? So like, is the argument that they have like an instance of the Redis cache for Redis graph, right? Then you have that over here. Then you have an instance of Redis, you have instance of the Redis cache for Redis search, or are they all kind of flowing to the same centralized place, which is even worse? So regardless of which solution that you pick here, like it has to be doing one of them, right? Or it's like partitioning. So if it's doing the first one where everyone is converging on the same fundamental data and it's stored in a centralized place, you have herding. Everyone for all their use cases are all going to be running towards the same direction. And if you have duplication of the data, then you do not get ACID compliance, because unless you have like a multi-write setup or a multi-write master setup, which I don't know if they do, then you can't get ACID compliance there. So let's see.
Databases. And secondly,
sorry, I said ACID compliance. I mean transactional compliance.
What you have here with Redis, each of those modules have the real functionality of a graph, JSON, search, etc. It's not just an API, okay? And we have, with the module system, we have people from the community built already many different modules. We have some enterprise customers that build their own proprietary modules even without sharing this with us. And then we as a company build modules which are intended to expand the use case coverage of Redis and make it multimodal. We would like to show you today how this works in reality, and for that we have built an application which takes the Twitter firehose and does the following. First of all, word count on the Twitter firehose, indexing and then searching, and then building a social graph out of the data. Let's see first how this could be implemented on the cloud, on AWS, without Redis.
Oh boy, this is going to be good, right? You know he prepped some example, and it's like, okay, guys, we're going to pick this example because this example shows you how complicated AWS is and how awesome Redis is. Not saying that like Redis isn't awesome, but I'm just saying like whenever you get these kinds of scenarios where it's like, oh, let's show you how complicated this is. It's like, okay, let's see what he says.
So basically, you take the data from the Twitter firehose, feed it into Kinesis, which is the streaming engine of AWS, and then you need to build a Lambda function which will take the data from Kinesis and move it to Elasticache, so the Redis sorted set can do word count for us. Then you'll have to build yet another Lambda function to take the data from Elasticache and move it to DynamoDB for persistent purposes. In parallel, you need to build another Lambda function to take the data from Kinesis and to move it to Cloud Search for indexing and all the searching functionality, and another Lambda function to take the data from Cloud Search to Elasticache for instant response. And in parallel, you need to build another Lambda function to take the data from Kinesis, to move it to Neptune, which is the graph data service of AWS, and from there to build another Lambda function to take the data from Neptune and move it to Elasticache for instant response.
Okay. So I let him talk for a little bit. So, I mean, he's kind of right. Like, if you want to do this kind of thing, then you need to kind of be cutting this data in multiple different ways. But like what this guy's arguing, like he wants the best of everything, right? He wants all these technologies to fit. Like he has a use case where he has some data and he's like, okay, how do I access this data in every way possible, right? I want fast lookups. I want durability. I want graph searches. I want word frequency indexes. How often does that actually happen in real life? Like maybe it can happen. I mean, this stuff can be like your Neptune stuff and your cloud search stuff could be like stuff after the fact, maybe for your analytics or something like that. But it's very rare that I think you kind of bundle all of these into the same data set. You usually kind of cut this across service boundaries and expose this in other ways. So like he's right in the sense that if you want this data to be reflected in all these different ways, be searchable by text, be searchable by nodes and graphs, and also have very quick lookups and durability, then sure, this is what you can get. You probably can do something simpler if you use DynamoDB streams here, but I won't get into that. But yeah.
And on top of all that, you need to build connectors from your application servers to each of those data services.
What does he mean? Like to access the data? You just hit the ARN, right? Okay.
Does this remind you of anything?
Yeah, it's complicated. Sure.
So, you know, in order to do that, we used 5 data services, 6 Lambda functions, 5 application connectors, and we ended up with 7 network hops.
Here it comes, guys. And guess how many with Redis? 1. That's what I'm saying.
Okay? Did I mention slow, complex, and expensive? Let's see now how to do exactly the same thing with Redis. So for that, we would use...
Of course. One thing, right? One thing.
Redis integrated with two modules. The first one is Redis Search and Redis Graph. And basically what we do is we will take the Twitter Firehose data, feed it into the stream functionality of Redis, and then use a sorted set for doing word count, use Redis Search to do the indexing and searching functionality, and Redis Graph for building the social graph. Very simple to do. We'll show you that.
Oh, I was off. 3.
We end up with one data service, 0 Lambda functions, 1 application connector, and 1 network hop. I think that no words are needed. This is so.
Some words are needed. The words that are needed is that you get all these benefits by giving away control, right? By using a product like this, you have no leeway to make any decisions about anything else other than you're going to use this product and that's it. You have to abide by its rules. And don't get me started with all the other problems where you have no durability, you have no transactions, you can't. There's a bunch of other issues here, right? I think he's greatly oversimplifying what this product does and the pitfalls that you can run into if you're using it. And I don't like the fact that once you go with this, you're bound to it because you're with the same provider and then you're using all these different modules. That's very Microsoft-esque of a thing to do. It's get you in the ecosystem. Here, okay, perfect. This is how this feels. What he's selling this is get into our ecosystem, and then once you're in our ecosystem, it's you're ours, right? You're mine now. You're in here for good. You're never getting out because you build your entire product around how Redis works. And this is a thing I tell a lot of people as well. A common problem of people when they're designing or trying to figure out how to build a solution for an application or whatever is that they start with the technology first. And this is the wrong way to do things, right? Sure, in some cases, maybe you want to do some kind of Facebook style application, right? Where it's very logically in your head. It's a connected graph, directional graph, or bidirectional graph. And maybe, for instance, you want to do something based on text search. So you may use something like Lucene, which is a great text-based searching engine, or Elasticsearch, which uses Lucene. And sure, in the back of your head, that's okay, I'm probably going to be using this technology at the end of the day. But don't start with the technology and say, okay, we're going to start with Elasticsearch. Let's work backwards from there. Because what ends up happening is that you get so fixated on the technology itself and you're not focusing on the domain problem anymore. You need to figure out the domain problem. How can we think about these things as logical units and then you figure out the technology later. Define your domains, define your relationships, and then figure out the technology at the last step. If you're good at designing services, what should happen is that your technology, your service design should be agnostic of the technology, generally speaking. With going with the approach where you pick the technology first, you're boxing yourself into a corner. So try not to get too far into that. Yeah, Painful, you have a good point. AWS is an ecosystem. So I'm kind of biased, but yeah. It seems let me rephrase that. I think AWS is an ecosystem, but they also give you flexibility to generally do whatever you want, right? If they don't have a product for what you're trying to do, you can always run EC2 servers, host the thing yourself, right? You can go down that path if you really want. This is how people were generally doing a lot of different things. Before Elasticsearch was announced as a product for AWS, people were building open source solutions where they had EC2 machines that were hosting this stuff. And that worked for a long time. Reading comment. Hey man, one of the biggest pitfalls we faced recently is everyone does development database design first. Build all the DB tables and then figure out the gaps. Put us in a huge bad place. Yeah, see this happens all the time. And I think you get this a lot from old school developers because I think this is an old school mentality where they want to start with those ERM models, man. Get those ERM models, get that friggin' one-to-many relationships defined, draw out the class structures. Yeah, you'll be rocking it. That naturally leads you down a path where you start to talk about databases. So yeah, just be careful about that. Yeah, so you can host anything you want, as you said, Paintflow. And yeah, I guess based on what we're seeing here, once you get on the Redis bandwagon, you don't really get off. So let's keep on going, though. I went off on a tangent here.
Than to do it with, with Polygon persistent architecture. We would like to demo it now, and for that, I would like to call.
Okay, he's going to demo it now. It's going to be the most pre-prepared thing you've ever seen. Just watch.
Kyle Davis. Kyle, hey, please come on.
Okay.
By the way, I don't mean to trash Redis in any way. I'm just saying that. I'm just saying that everything's got problems, and it's not fair to sell something as being this perfect little thing, but not at least talk about the problems or acknowledge that they exist. That's what bothers me.
All right, let's see if everything's still up.
Come on, Kyle, show us
So
what you
I'm going to
got.
do today is take the Twitter fire hose, as we said, and I want to use a Redis stream to pull it in and start using that to turn it into a Redis stream. So as we can see here, I'm doing that. I just want to check on something momentarily. Yep, we're getting tweets. Okay, so then what I'm going to do is I want to do that word counting thing, right? I want to create a word frequency chart. So I'm going to do that. And let's take a look how that looks. So we're live generating this particular word cloud and frequency chart.
Of course, Trump is the top thing, right?
As we go along.
What date is this from? This is from 2018, man. They should do one for today. Probably be pretty consistent.
By just using sorted sets and some interesting stuff like that. You might guess what keyword I'm using. I make no adherence to what the content is. This is the live internet, so.
Amen. Live internet.
There's that. Then we're going to say, okay, we look over here. This is some really interesting stuff, right? We can say, okay, what's going on with this? So let's take a look at something here. Think. I just saw that keyword, right? So I'm going to go over here. I'm going to look in search. So let's go to the search engine. I've turned that on. Now we're indexing live as we go along. So let's take a look at search and how that looks. So as I type, I'm searching through this stream of data. We can see everything here. This is using Redis Search, which is a real-time search engine that we've built. I can go in and let's see here. Let's do Macron, right? That's what I was looking for. RON. Okay. Faker Monica. Okay. I have live internet, guys.
Oh boy. He better be real careful.
Name. So I'm going to use it as a secondary index here. And we can see all the things that this person has.
I could just imagine this going horribly wrong.
Tweeted, which is really interesting, right? But we can also see like where they've mentioned as well. So we can see at mentions int. I can't type today.
He's nervous.
We can do that.
It's okay. I
So
get
we can see
camera
right
shy
who's
too.
mentioned the ACLU, for example. That's really interesting, right? But what if we wanted to see, for example, how these all related, right? That would be a graph problem. So I can go ahead and go over here. We'll turn graph on. And then we can see how everybody is.
This thing probably does nothing, this UI that we're looking at. It's probably just like a thing that he's coming just to say that, oh yeah, I'm turning something on.
It's connected. So I'm going to make this a little bit larger here. And let's take a look at the social graph of what we've been ingesting. So then we can see the social graph. And let's take a look a little closer at this. Zoom out a little.
Where's Trump? Find me Trump.
And this is all built using streams. And this is Redis graph, which I'm going through and seeing the relationships between people who've mentioned things. And we can see some interesting relations. Let's take a look here. Let's look at the hill, which is, and we'll take a look here, recenter that. We can see who's said things here, and we could take a look at one of these people and see who they've interacted with as well.
Okay, so I think this is just going to be more of that. Yeah. Okay, so
Thanks.
I think we've learned a little bit here. So what do we learn? Well, the guy was presenting this in a way that wasn't really fair. We learned that Redis has all these different modules where you can hook in to get all these different functionalities. This may or may not create a single point of failure, which is relatively unknown. We probably need to go into the low-level documentation to know more about that. And it seems like once you get into the Redis, once you have your Redis Kool-Aid, you cannot stop. So that's what I've learned. So let's go to their website. I saw that they have like a tutorial or something that we'll do and just walk through what it looks like from the usability perspective. So maybe before that, maybe they have like a summary article. Okay, so let's just go through this. Redis is an open source in-memory data structure store. It uses a database, cache, and message broker. It supports data structures such as strings, hashes, lists. Okay, so question about this. Does it use this stuff in the sense that you can store these types? Or can you look up by, for instance, like criteria other than the key is what I'm trying to say. So can you look up something based on its geospatial properties, right? That's not answered here. What I would like to know though. It's got built-in replication, Lewis scripting, LRU eviction. Ooh, LRU, nice. Transactions. Okay, transactions. That's interesting. And different levels of on-disk persistence, and provides high availability via Redis Sentinel and automatic partitioning with Redis cluster. Let's learn more before I get to the tutorial. Okay, that's pretty much what I just read. You can run atomic operations. Let me make this bigger too. You could run atomic operations on these types, like appending to a string. Okay. Incrementing the value in a hash. Pushing an element to a list, computing settings. Okay, so this is kind of cool, right? So they're saying here that you get some bonuses, you get some freebies. So how you would normally have to do this with a cache, if like you want to append to a string or something, you would need to go grab that value from the cache, take it back, examine it, add the thing back to, add the character or whatever to the end of the string, put it back into the cache, right? So it's like 3 or 4 trips there. And so it seems like they have something like, I can't remember what the name of this thing is, but you know, like when you write to Dynamo, you can say only update this field. I can't remember what this thing is called. I know it's the thing though. Maybe someone can remind me. But it seems like they have some similar functionality where you don't need to like pull the object back, make your modification, save it. You can do these kind of basic operations on it without having to pull it out. So that's kind of cool. I wonder if they have like, I know Dynamo has like write conditions where only perform this operation if this thing is satisfied. So I wonder if that is supported here. So in order to achieve its outstanding performance, Redis works with an in-memory data set. Depending on your use case, you can persist it either by dumping the data set to disk every once in a while. Oh, don't do this to me. Or by appending each command to a log. Persistence can be optionally disabled if you just need a feature-rich now work in-memory cache. Oh, I want to click this so bad and read this. Should I do it? Not for this. Hold on. Let me just peek. Append only file. I'm going to read it really quick. Okay. It's too much for this stream. Maybe another time. Other features include transactions, pub/sub. So this is cool. Like you get SNS, SQS kind of thing out of it. Lewis scripting for plugins. Keys with LRU. Well, that's the next one. Automatic failover. Okay. It's written in ANSI and works in most projects. Update attribute on item in Dynamo. Yeah, that could be it. It could just be the update API. Redis works in Solaris derived systems. Okay, that's fine. So, I mean, I think I learned pretty good amount. Let's try to do this tutorial thing now and see what this is about. Oh wait, I don't want to make this too small, too big where you can't see the screen anymore. Okay, so how about that? All right, let's see what we got. So welcome to Try Redis, a demonstration of the Redis database. Please type tutorial to begin. Okay, tutorial. What do we got? Redis is in the family of databases called key value stores. Right. The essence of a key value store is the ability to store some data called a value inside a key. This data can be later be retrieved only if we know the exact key to store it. So this is what I was talking about before. Usually you only have key-based lookups for caching solutions. Often Redis is called a data structure server because it has an outer key value shell, but each value can contain a complex data structure such as a string, a list, hashes, order data structures such as sorted sets, as well as probabilistic data structures like a hyperlog. As a first example, we can use the command set to store the value Fido at key server name. So set, if I click that, oh, okay, so if I just click it, it does the thing. Nice. Redis will store our data permanently, so we can later ask, what is the value stored at server name? And Redis will apply Fido. It did. So let me try. Set foo bar. Okay. Get foo bar. All right, cool. There's a command in order to test if a given key exists or not. Server name is 1. Okay, that's cool. So it tells you, it's kind of like a peek operation to tell you if it's there or not. You can click the commands above to automatically execute them, blah, blah, blah. Okay, that was neat. I hope I'm not using this kind of syntax when I actually start running this thing. I hope it's got like some kind of ORM for Java or Python and all that stuff, because this seems mad. It's almost like friggin' learning a new SQL language or something. Other basic operations provided by Redis are del to delete a given key, increment to automatically increment a number stored at a given key. Ooh, connections. We have to worry about connections? Or are we caching the value connections? Probably that, right? And then, hold on, I want to do get connections. Okay, so the increment worked. Okay, so if I increment it again, I should get an error or something, right? Huh? I just deleted it. Oh, okay. I guess it starts at 0. Get connections. So is it 1 now? Okay, interesting. So if it's not there and you try to increment something, I guess it assumes it's at 0 and increments it to 1. It's also possible to increment the number contained inside a key by a specific amount. Ooh, that's cool. So increase by 100. Nice. And there are similar commands to decrement the value of the key. Okay, that's kind of cool. When you manipulate Redis strings with incrementing and decrementing commands, you are implementing counters. Wait, hold on. When you manipulate Redis strings with incrementing and decrementing commands, you are implementing counters. Counters are a very popular application for Redis. Okay. I'm convinced. There's something special about increment. Why do we provide such an operation if we can do it ourselves with a bit of code? After all, it's as simple as true. Good point, sir. The problem is that doing the increment in this way will only work as long as there's a single client using the key. See what happens if 2 clients are accessing this key at the same time. Client A, so this is a race condition he's describing. So he's telling us that, oh shoot, sorry Farzad. Yes, I will move my webcam to the top left. We're just jumping around today. So what he's saying here in this kind of little blurb is that, say you, for instance, like you have this value stored as 10 in your database, right? Or in your cache. Client A reads 10, client B reads 10, right? Client A increments it on the local side because it thinks it's 10, so it goes to 11. Client B does the same thing. They both think it's 11. Client A writes back to the cache, it sets it to 11. Client B writes back to the cache, also sets it 11. 2 operations were performed, only one thing actually changed. So this will be solved if you have, well, it's not solved because it seems like they don't have any concept of state. So you're just like setting the value to 11. You're not incrementing something in a transactional way where anyone that's reading it will get the updated value. So typically how you handle this in things like DynamoDB or SQL engines is you use something called a write condition, or like an optimistic locking condition. So for instance, what you do is, so I use Java a lot, and I use DynamoDB Mapper. And with DynamoDB Mapper, you can do something you can include something called versioning. It's DynamoDB version annotation if you're using the DynamoDB SDK. And when you set this value to be of type version, what it's basically saying is that once someone makes a change on this row, that version value gets incremented every time, right? So say it starts at 0. Now, when someone makes a write, it gets incremented to 1, okay? Now, in order for someone to make a subsequent write, they would first need to get that object back and perform the modification, then write it back. So there's always that get before the write. And then on the Dynamo side, since you incorporated the version attribute on that field, it'll say, okay, if you have a row, like if on the Dynamo side, the value is 1, right? And on the client side, so after you pull the value back, you have value 0. That means when you pulled it back, you have an out-of-date value now. And when you try to write to Dynamo, there's going to be a mismatch, so it'll fail your transaction. So you'll get an optimistic locking exception back. So this is a good way to kind of coordinate writes so that threads aren't stepping over each other, which is essentially what they're describing right now. I don't know if it's the same. I don't know if that made a lot of sense for some people. That was kind of hard to explain. You can look up DynamoDB Mapper versioning. Kehan, JPA in Java has the same versioning for SQL databases. Cool, that's good to know. I believe like there's optimistic locking and then pessimistic locking. So optimistic locking is where you take the risk of writing and you can potentially run into the problem where I just described. And pessimistic locking is when you lock the row, no one else can read, no one else can touch the row until you release the lock. There's pros and cons for each of these things. Okay, so we wanted the value to be 12, but instead it's 11. That is true. This is because incrementing the value in this way is not an atomic operation. Calling the increment command in Redis, this was the word I was looking for, atomic operation. Calling the increment command in Redis will prevent this from happening because it is an atomic operation. All the Redis operations implemented by single commands are atomic, including the ones operating on more complex data structures. So when you use a Redis command that modifies some value, you don't have to think about concurrent access. That's cool. But can you, though? Like, what if you want to do something more complicated? What if you want to, like, change something out? Like, swap a value out or, do some complicated math on something, So do you have to write a module for that? Or do you just have to accept the fact that writes aren't atomic and someone could potentially overwrite with whatever I'm writing and like basically clobber my results? Oh, that's the term in Dynamo. It's called clobber, where you clobber over someone else's write. So you basically just like, literally like the word says, clobber them, So you take their place essentially. Okay, so you don't have to worry about concurrent access, but it's an important thing to think about if you're building applications, especially if you have like scenarios like this, where you have especially distributed applications. Yeah, let's keep going. Redis can be told that a key should only exist for a certain length of time. This is called TTL, if you've never heard of this before. This is accomplished with the expire and TTL commands. By the way, TTL stands for time to live. If you hadn't heard that term before, it basically just means that when should we kick out this value from the cache? When should we not have it there anymore? And so the neat thing about LRU caches is that typically they reset the TTL duration anytime there's a read on it or a write. Like it depends how they're implemented. So, if you have something in the cache, it's not read for a long time, and then someone pulls it back to read it, it won't necessarily get it won't use the initial TTL to use the refresh value. So that's kind of cool. And by the similar p-expire and pttl commands that operate using time in milliseconds instead of seconds. Okay, so there's a subtle difference here. I'm not sure if you guys caught it. So what they're saying here, I believe, is that you're able to set either an offset. So say, for instance, like your TTL is 24 hours, right? So that's one option. That's normally how TTLs work. You just kind of set an offset of however much time you're willing to wait. The other option is a specific point in time. And this is dangerous. And I'll tell you why it's dangerous in a moment, but let me just explain this. So you set the TTL to say midnight of every night, okay? Generally, you never want to do this because you get a phenomenon that's called stampeding. And it literally means what you would think. So if your cache is set up so that your data expires at midnight, think about if you have like 10 or 20 or 30 EC2 machines that are all trying to read that cached value now, right? Everyone's going to be hammering that cache. And if it's partitioned or sharded in some kind of, reasonable way, all the queries may be hitting a particular instance and just brown out that application. That's called cache herding. And it's a herding. Stampeding. Sorry. Herding. No, herding is different. Stampeding is the concept. Anyways, so I went off on a tangent there. So set resource lock. So we're setting a value. Okay. And then we're going to expire in 2 minutes. Okay, the time is ticking. The -2. Is it? Oh, okay. Okay, get. How do I see what the duration left is? Oh, cool. Okay, so it's this command. TTL resource lock tells you how much time is left. Okay, so after this amount of time, then it's a negative value. Means that it doesn't exist anymore. A -1 for the TTL of the key means that it will never expire. Ooh. Kind of cool that it supports that. So things like constants, if you have like an ID of a field that's never going to change, it's good to have. Note that if you set a key, its TTL will be reset. Okay, so this is the functionality I was talking about. So it's not, or like the implementation dependent functionality. So normally, it's a toss up. Some of these solutions, they'll reset the TTL on the get in addition to the set. Looks like Redis has taken the stance where they just reset on the set. So that's kind of cool. Set the resource. Okay, so set the value. So let's follow these. Okay, it like kicks me down every time. That's really annoying. And I'm just going to read this actually. So we set the TTL resource lock, and that returns 119 now. And you set it to 2. What happened here? It means that the key will never expire. Set resource lock Redis limit to TTL. Oh, you're setting it. Oh, he changed the value. Okay. So he changed resource lock from Redis demo 1 to Redis demo 2, and now the value is negative? Wait, hold on. A -1 for the TTL means that it will never expire. Okay, so after you reset a value, it wipes out any TTL rule that you had for that value. So that's, I guess, the same thing that I was saying before, but wait, this is weird. Okay, so correction. It doesn't reset the TTL counter. So say, for instance, if you set var x, right, to foo, and you set a 2-minute TTL on it, and then start counting down, right? 5 seconds later, you set var x to bar. The TTL doesn't get reset to 120. It actually removes the TTL behavior. So that's what they're demonstrating here. Okay, so that's cool. The set command is actually able to accept further arguments in order to directly set a time to live. So this is what I was talking about before. So be careful about herding. So you can alter the value of a key and set its TTL at the same time in a single atomic operation. X5, what does X5 mean? I don't know what that means. Like 5 minutes from now? What is that? I don't know what that means. It's also possible to cancel the time to live of a key, removing the expire, making the key permanent again. Okay, cool. I guess the equivalent would just to be reset the value, but that works. Go into the next. Redis also supports several more complex data structures. The first one we'll look at is a list. A list is a series of ordered values. Some of the important commands for interacting with lists are rpush. So right push. So this is a push. This looks like it's a pop. Length of the list, the range, left pop, right pop. Okay. I'd have to read each of these individually to see what they're talking about. You can immediately begin working with a key as a list as long as it doesn't already exist as a different type. So there's no, I wonder what happens if you try to do this. Reset a value with a different type. I wonder if it throws an exception or what. This concept is generally true for every Redis data structure. If you don't create a key first and add things to it later, but you can just directly use the command in order to add new elements. So the key doesn't have to exist. You can just use one of these commands to automatically add elements without doing the initial insert. As a side effect, the key will be created if it did not exist. Generally, that's like upsert is the term. Similarly, keys that will result empty after executing some command will automatically be removed from the key space. Okay, that's all right. rpush puts the new element at the end of the list. Okay. lpush puts the new element at the start of the list. Also good. lrange gives a subset of the list. Okay, so there's like sublist kind of command. Takes the index of the first element you want to retrieve as its first parameter, and the index of the last element you want as its second parameter. Value -1 for the second means to retrieve elements until the end of the list. So you can say, get me between these two ranges, or get me between here and to the end. I'd assume they have something similar from like here and to the beginning. So in the opposite direction. Okay. Useful. So just as like a quick pause here, just to recap. So it seems like they have some very cool functionalities so that you don't need to like retrieve values back and do all these modifications. You can potentially like do inline modifications without having to perform many of these changes yourself. But the question that naturally arises is like, what if you want to make major changes to an object? You need to like sequentially apply these things or what? Like, how does that work? So I'm going to try and find the answer to that. So far, we explored the commands that let you add elements to the list and lrange that let you inspect ranges of the list. Fundamental functionality of Redis lists is the ability to remove and return to the client at the same time. So this is like a pop. Yeah, pop. Elements in the head or the tail of the list. Okay, so take from the beginning. So take it out of the list, give it back to the client. Take it out of the end of the list, give it back to the client. And then it's just doing range checks down here again. I believe them. Both rpush and lpush commands are variadic. I don't know what that word means. So you can specify multiple elements in the same command execution. Oh, cool. So you can push multiple. Neat. So like a batch write, batch save kind of thing. And then he's checking the length. All right. Both down here. The next data structure that we'll look at is a set. Set is similar to a list, except it does not have a specific order, and each element may only appear once. Both the data structures are useful because, I think we all know what sets are. In a set, it's very fast to test for membership. That is, to immediately know if a given element was added or not. A given element can exist only in a single copy. So some of the important commands working with sets. So set add, set remove. So this is the test command to get everything, and then the unions of two sets. So yeah, this is pretty neat. Standard stuff though. SRAM removes the given member from the set, returning 1 or 0 to signal if the member was actually there or not. Okay, good to know. And now he's just explaining all the things. So is member tells you if it's in there or not. This one tells you if it's not in there. 1 for is there, 0 for is not. This gives you all the items as members, and union gives you the union of the two. So pecking and flight. What do you do here? One pecking. Wait. S union combines 2 or more sets and return. Oh, okay. So appending, summing the sets. Okay. S add is important as remove. If the element we try to add is already inside, then 0 is returned. Okay, covered that. Sets also have command very similar to lpop. Sorry, I'm just skimming through this now because they're being very redundant with this. Command to return random elements. Why would you ever want to do that? Okay. Gonna move through this part pretty quickly, I think. What is this? Sets are a very handy data type, but as they are unsorted, they do not work well for a number of problems. Sorted sets. A sorted set is similar to a regular set, but now each value has an associated score. This score is used to sort the elements in the set. Okay. In these examples, the scores are years of birth and the values are the names of the famous hackers. Scores are the years of birth and the values are the names of the famous hackers. Range 2, 4. Z range. I don't know what this does. So Claude Shannon, Alan Kay, and Richard Stallman. Oh, because if you sort by the year here, the order would be like 2 and 4 would be, I guess, these guys. Like what's between 2 and 4, because it's a range lookup, right? So 2, 3, and 4 would be in order Claude Shannon, Alan Kay, and Richard Stallman. So let's just test this. Is this the lowest value? Claude Shannon, 1916. It's not. Grace Hopper is. Oh, okay, but we're starting at 2. Okay, this makes sense. Too much time spent there. Simple strings. Sets and sorted sets already got a lot done, but there's one more data type Redis can handle. Hashes. Okay, great. Hashes are maps between string fields and string values. They are the perfect data type to represent objects. So this is normally what you see when you're working with caches is key-based lookups where you can store any kind of dynamic object that you want. It could be a list, it could be object, whatever. Yeah, normally you have some constraints though, so it's interesting that they don't really seem to be applying those. So we set the user. So okay. Oh, interesting. So for this key, let me take Sublime here really quick to show you what I think this means. So what I think this means is it's like this. Oh, wait. Right, and then you can have multiple, and then email, blah, 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 right? Because we're referencing the same person, and then we're just setting this value. Oh, we're setting the value of this key to this thing. So this is the value, this is the key, this is the primary key of the cache. And then you want within that, the name key, its value to be John Smith. That's how I'm interpreting this. Not bad. You can have some complex objects, it looks like. To get back the saved data, use hgetall. So this is probably what you're going to be using pretty frequently. So this is kind of cool, actually, that they let you pick. Like, I haven't read this part, but this part down here yet. But I assume that you're only, if you want, say you only want to get the name, right? You can get it by name. So if we look down here, so we're setting the name. Okay, down here he's saying hget for this user. I only want to get the name key. Using Mary Jones here, but it's the same effect. So it's a selective lookup. So you're not getting the whole object back, but you're getting just a component of that object. Kind of cool. So the advantage of this, if it's not clear what the advantage of this is, it's that you're offloading there's multiple advantages. Less stuff over the wire, right? You're not transmitting as much data. It's probably easier on the Redis cluster because, again, you're probably not pulling as much data. The third one is that if you assume that you got all the data back, it's bad from a client perspective because now I need to serialize all that data. I need to map it into some kind of object before I can finally use it, right? And this takes forever. And especially I don't know if you guys know, but like deserializing and serializing are really inefficient operations, especially if you have big objects. They're really, really bad. So this is a nice to have feature, I have to say. So if that wasn't clear, like hgetall gets everything, and then you can set particular keys within this user, and you can set them as you can see here. And this is kind of in a batch, so like a one-liner, as opposed to this one's happening in 3. So that's neat. Numerical values in hash fields are handled exactly the same as simple strings, and there are operations to increment this value in an atomic way. Okay, so this is what we saw before. So it seems like what they're saying is everything you can do on just numerical values, you can also do on them when they're stored in these sorted sets or hash maps. Oh, is that it? That wraps up the Try Redis tutorial. Please feel free to goof around with this console as much as you like to. Check out the following links. What do we got here? Oh, this is a lot. This seems like what we just did, right? Yeah, this seems like it's what I just did. I want to see if there's like object relational mapper for this. Clients. Because I don't want to be writing like this craziness, right? No, surely no one does this. But let's see. Clients. Clients with some activity, official web. Okay, so good. It seems like they have. Okay, Java. Give it to me. Oh, wow. Okay, so there's open source. So nothing really like. Wait, what did that say at the top about the star? Oh, recommended is star. Okay, so they recommend Redis, something called Lettuce. I just don't like that name. Redison. Okay. Cool. So I'm interested in this one. So I may have some kind of follow-up video here where I actually set up a cluster. Hopefully I can set it up on my local. Because I think it'd be pretty fun to just test this out and see what it's got. But what does the syntax here look like? Okay, here we go. Okay, so it looks like you can set it up on local. I'll probably spin that up in like a Docker container or something. I'm not going to be doing that in this video, but in a different video. Okay, cool. All right. So as an added bonus, I'm going to give you guys a preview of my new video that's coming out soon. Well, one that I worked really hard on. So I want to get some feedback on it. And so I'll show it to you guys. If you give me a second. So the video is about JavaScript and the fundamentals of JavaScript. I was trying to like just different topics to see what I can do. And so I decided I wanted to try this because I mean, it seems like it's a pretty common topic and lots of people are struggling with the fundamentals of JavaScript and where to start, especially in like the web development community. So I figured I would try to put something together. So let's give it a watch. Oh,
okay, come on now.
No ads.
I just need to add one more log line. Rebuild.
According to Git. Okay. Here we go. Did this work? All right. I'll be quiet now. According to GitHub, JavaScript is the most popular programming language in the world as of late 2019. And for good reason. It's easy to use, has familiar syntax, and can be used in a wide variety of programming environments. But how did this all start? How did we go from JavaScript being a taboo programming language to the most popular programming language in the world? Let's talk about its history and how it came to be. So first of all, what is JavaScript? JavaScript is the programming language of the web. It was created in 1995, and at the time, it was predominantly used to add behavior to websites. Things like making it so that when we click a button, something actually happens. This example is something we all take for granted now, but it was a huge deal at the time when websites were super simple and predominantly read-only. Take a look at Amazon's first website and you can see what I mean. And take a look at it now. In order to understand why JavaScript is so important, let's take a look at how any standard website is built. We have the HTML, which is the general structure of the page. We have something called CSS that controls the style of the page or how things look. And finally, we have JavaScript, which can dynamically change both the structure and style of the page in response to user actions. JavaScript does quite a bit more as well. All this rich dynamic behavior that you experience every day is driven by JavaScript. In the past 10 years or so, JavaScript applications started to get really complicated. So the community built libraries that simplify how developers build these applications. Some examples of these libraries are familiar ones like React, Vue, Angular, and more. These libraries aren't mandatory, but they sure make your life a whole lot easier. In recent years, JavaScript has become insanely popular thanks to engines like Node.js, which allow developers to use JavaScript not only to build just websites, but to use it for other things such as hosting standalone applications, talking to databases, and talking to other services. The flexibility of JavaScript, both on the front end and the back end, have been a major contributor of its long-term success. So that's what JavaScript is and how it came to be. Now let's talk fundamentals. In order to get started with JavaScript, you need to have a grasp on the language's structure. The most basic building blocks of any programming language are called primitives. In JavaScript, the primitives consist of numbers like 1, 2, 3, 3.5, 99999, strings such as hello world, booleans, which are true and false values, lists, which are a series of things, and objects, which are containers for combinations of other primitives. Objects also let you create dictionaries of items so that you can quickly look them up later. Think of an object like a phone book. If you know a person's name, you can look it up and find their associated phone number very quickly. Outside of primitives, we have the usual control structures such as if-else statements, which are used for branching logic, for and while loops, which are used to examine multiple objects in a list, one at a time, and try-catch statements, which are used to handle unexpected errors during your program's execution. We use the terms var, let, and const to declare references to instances of primitives or objects. Var is outdated and rarely used. Let allows you to temporarily assign something that could change later. And const allows you to permanently assign something that will never change, like the constant pi. The other important aspect of JavaScript are functions. Functions allow you to wrap a bunch of behavior into one variable. For instance, when you attempt to pay a bill on your bank's website, the website may need to do several things such as verify your identity, make sure you have money in your account, and finally perform the transaction. These three sub-steps can be wrapped inside one function called payBill. These three smaller steps can also be functions that do separate things. You can quickly see how we use functions to create some rich behavior. JavaScript itself isn't that complicated, but it's hard to know where to go next, and there's a ton of conflicting information out there. So what now? Where should you go to learn more? I highly suggest you take the JavaScript course on Code Academy. It's an online interactive course that teaches you the concepts I glossed over here. So I've talked to you about the fundamentals of JavaScript and hopefully enough to get you started. Now it's up to you to take the next steps. As always, if you enjoyed this video, please don't forget to like and subscribe so that you don't miss out on my next one. Thanks so much, and I'll see you next time. So, what do we think, boys? Thoughts? Distributed transactions for Kahan. Yeah, that's a cool topic. I was actually doing some reading about distributed transactions, particularly with concerning RDS, and I just learned that you can have a multi-master RDS, and the suggested guidance is to shard your data in such a way where they're not going to be clashing with one another because there's like some complicated rollbacks that can occur. I think it's an interesting topic. I'll look into it a little bit more and see if I can put something together. Cool. Thanks, guys. Good comments. Nice. But yeah, I'll definitely look into that topic, Keon. Let me know if I interpreted that correctly. If not, let me know. And or if you're looking for something specific and for a specific technology or something, or just broadly. Okay, so I think I got through everything that I wanted to talk about today. Appreciate you guys taking the time to stop by. I learned a lot. Hopefully you guys learned a lot too. I think Redis is pretty interesting. Probably in my next one I'll set it up and just do some stuff locally, probably using that Java library, Redis or whatever it was called, or Redis. But yeah, thanks everyone for stopping by. Appreciate you taking the time. Have a great night, guys. Take care.